Today, let's find out more about the relationship that exists among the volume of a right circular cone, a hemisphere, and a cylinder of the same height and radius. Before we start, here's a quick recap on some concepts. A right circular cone is a cone in which the vertex is aligned directly above the center of the circular base. A right circular cylinder has two congruent circular bases perpendicular to the lateral base. A hemisphere is half a sphere, so two hemispheres make up a sphere. Here we have with us two hemispheres of a sphere. We'll use one of these hemispheres for the activity. We'll also need a circular cone and a cylinder whose height and radius are equal to the radius of the hemisphere. We've already kept the models ready, and here's how they look. A right circular cone and a right circular cylinder. Note that the circumference of the hemisphere is equal to the lateral surface of the cylinder. The radius of the base of the cylinder corresponds to the radius of the hemisphere. Now, here's adding some fun to the activity. To determine the relative volumes of each of these, we'll go ahead and fill the models with sand. Remember, the radius of the circular parts in all three models is the same. The height of all the three shapes is also the same. What do you think? Will the volume of all three models be the same? Let's find out. Here we go. Let me start filling this cone with sand. Now, let's pour it out into the hemisphere. The hemisphere is not full yet, so I'm going to take another cone full of sand and pour it into the hemisphere. The hemisphere is now full. What can we infer from this? Yes, the ratio of the volumes of the cone and the hemisphere is 1:2. Similarly, let's use the cone and fill the cylinder up with sand. Filling it once does not seem to be enough. Let's fill it up again. No, it's not full yet. Let's try filling another cone full. The cylinder is finally full with 3 cone helpings of sand. With this, we've arrived at the ratio of the volume of the cone to the volume of the cylinder, which is 1:3. We can conclude from this simple activity that the ratio of the volumes of a cone, hemisphere, and cylinder is given by 1:2:3. The result can also be verified mathematically. We started the activity by taking the value of radius r as 6 cm and height h as 6 cm. Go ahead and substitute the values in the formula to verify the result. Remember, The volume of a right circular cone is 1 by 3 into pi r square h. Volume of a hemisphere is equal to 2 by 3 pi r cube. And the volume of a circular cylinder is pi r square h. This brings us to the end of the activity. We've proved that the ratio of the volumes of a cone to a hemisphere and to cylinder is given by 1:2:3.